Good morning, my dear students. In today's class, I am going to discuss about pulse repetition frequency and range ambiguities. Pulse repetition frequency is the rate at which the pulses are transmitted is called a pulse repetition frequency, and the echo signals that are arrived after an interval exceeds the pulse repetition period are called a second time around echoes. And then these second time around echoes will lead to the errors in the range measurements and will create a confusion in the range measurements. Suppose I consider three targets. I am assuming three targets are there. There are A, B, C. By observing this waveform, first I am transmitting one pulse. All echoes from all targets should come within this period only, before the next pulse. In this gap only, all echoes has to come, but only target A echo is arrived. That means target A is a unambiguous echo. Target A is an unambiguous echo. The target B and target C are my second time around echoes because they are occurred after the second pulse. This is the second pulse. The target B occurs after the next pulse. Target C also. That means target B and target C are second time around echoes, but target A is unambiguous echo. That means the target A range measurement is correct, but target B and target C range measurements are wrong or error because they are second time around echoes. And then the one method to distinguish multiple time around echoes from unambiguous echoes is to operate with varying pulse repetition frequency. By varying the pulse repetition frequency, we can distinguish multiple time around echoes from unambiguous echoes. And next one is transmitter power. Already we know the radar range equation. R max equal to PT G sigma AA by 4 pi whole square S minimum whole power 1 by 4. And let us assume the transmitter power is PT. Then we are transmitting a rectangular pulse train having the pulses having width of tau and pulse repetition period of Tp. Then average power is given by average power equal to transmitter power Pt into duty cycle. Duty cycle is given by pulse width by total period. The average power equal to transmitter power Pt into duty cycle, where duty cycle is pulse width by time period. 1 by time means frequency, therefore that is written as Pt into tau by Fp. From this equation, the Pt can be written as P average by tau into Fp. Pt equal to P average by tau into Fp. This can be written in the modified radar equation. Already we know that the radar range equation R max whole power 4 equal to PTG sigma AE n into EI of n by 4 pi whole square KT naught Bn Fn S by n of 1, and by substituting PT equal to P average by tau into FP, we can get this equation. This is the radar equation in terms of average power. Next, we can define the equation in terms of energy of the pulse. The energy of the pulse equal to PT into tau. This also can be written as P average into TP, that is equal to time period can be written as 1 by FP. Therefore, P average by FP. EP equal to P average by FP. Previously, we got the equation in terms of average power. By substituting in that equation P average by FP by EP, we can get ET G AE sigma n into EI of n by 4 pi whole square KT naught Bn into tau Fn S by n of 1, because we are substituted P average by FP by EP or ET. Okay. This is about the today's class. In this class, we discussed about the pulse repetition frequency, what are the second time around echoes, and the radar equation in terms of average power and energy of the pulse. Okay, thank you very much. In the next class, we are going to discuss about radar cross section and various losses associated with the radar system. With that, the first unit is completed. Thank you very much.